Hi everyone, Professor Christina Silver from Cal State Long Beach speaking here. And in this video, we'll be talking about contingency tables and conditional probability. A contingency table is what you see on the screen. It's just a chart to organize different information that helps with conditional probability in most cases. And conditional probability is a probability where you know more conditions. That's literally all it means. But we're going to go over it together in this example from your textbook. Here's the example. Suppose a survey of 100 randomly selected state university students resulted in a sample of 60 male and 40 female students. Of the males, two-thirds graduated from a high school in the state, whereas the remainder had received high school diplomas out of state. Of the females, three-fourths were from in-state schools. This information is represented in the following contingency table. Now, before we move on, I first want to apologize for my cat Sophia meowing in the background. And secondly, I wanted to say that I took this example straight from your textbook, and I wouldn't have made a distinction of the students between male and female. This is because there's this misnomer that people say if your gender is male and your gender is female. That's incorrect. Male and female are terms that represent sex, and typically it's the sex assigned at birth. Um, and that is different than the sex people could have in the future or who they are in their authentic selves. I thought I would keep it in here just to have that conversation to talk about how sex and gender are separate, and male and female are not terms that represent gender at all. If I were to have created this example myself, I wouldn't represent the separate groups as male and female. I might do like first year students and second year students because you can still separate out students without bringing in their sex or gender. Moreover, we know that gender is non binary. So, just a conversation I want to talk about to be more cognizant of different people and how we're all different and special in our own special way. Enough of the feels for now. Let's talk about the math. If you have more questions about sex and gender, or you want to share with me anything, I'm happy to talk whenever you are comfortable. That being said, let's go over the example from the book. The book talks about 60 males in the example. We see that over here. Let's actually use the highlighter. So 60 males in the male row, 40 females in the female row. Now, a little bit more is going on here. Two-thirds of the males graduated from a high school in state. So, in state is the first column. That 40 is 40, two-thirds of 60. You betcha. And then of the females, three-fourths were from in state. Is 30 three-fourths of 70? Absolutely. So that means that the 20 and 10 represent the one-third of males from high school out of state and one-fourth of females from out of state. We just talked about what all the different terms mean, but in general, I will just say that each number represents two characteristics of each student. So a student might be male and from an in-state school, and they would be in the green group of male and in-state students. Is it possible to think of this as a probabilistic situation? How? Yeah, think about all of the students in a room. All 100 students are in an auditorium or in a Zoom room. And I'm going to randomly pick one or say, okay, everybody who's male, raise your hand. And they raise their hand. I say, okay, now if you're male and you graduated from in-state high school, wave your hand back and forth. And so you would be able to see those 40 of the 60 arms moving around. Or maybe you'd say, raise your hand if you're female. And you'd have 40 females raise their hand. And then you'd say, now stand up if you went to an in state high school. And you'd have 30 females with their arms raised up, standing. And then you would be able to see of those 40 students, the 30 that went to an in state high school. So that's why it's probabilistic. If you randomly select a state university student, what is the probability that the student is an in-state high school graduate based on this information? So they want us to find the probability of I, and I represents in-state student. Well, that's going to be the number of in-state graduates out of the total sample space. Well, we know there's 100 students. And in-state students. There's 40 male in-state students and 30 female in-state students. So there's 70 students in total. And I'm going to color coordinate that. We'll have it be gray. Gray is in-state. We got that from right here in the in-state column. All right, let's look at the next question. What is the probability that the selected student both graduated in-state and is female? So I want a student who graduated in-state and is female. Well, there's the probability of in-state and female. That's the number of students who are in-state and female, and the number of students in total. Well, there's 100 students in total. I want students, and then let's use, instead of gray, we'll use brown. Students who are female and in-state. Notice the overlap happens at 30. So probability of in-state and female is 30 out of 100. Are I and F independent events? That means, is there only in-state students and they're all male? Are there only female students and they're all out of state? No, we have a mixture of students who are in and out of state, so I can't just multiply them together in that way. What is the probability of I or F? So in-state or female. We talked about this formula in a previous video, but that's the probability of in-state plus the probability of female minus the probability of in-state and female. I know that there's 100 students in total. Let's make this group this pretty lavender color. Let me erase some of the highlighting just so it's less cumbersome. I want in-state or female. So in-state is all of this column and female is all of this row. I'm really only looking at the colored boxes inside of this pink space. Notice I colored that 30 twice. That's where that subtraction comes in. I don't want to double count, but because we have a contingency table, I just look at each box that's been colored. I have 40 plus 30 plus 10, that's 80. So in-state or female, 80 out of 100, 80%. The next question, what is the probability that a selected student graduated from an in-state school given that the student is female? What this means is that we're in our room or we're in our Zoom room, right? And I said, okay, I know that I'm going to break you up into breakout rooms. You have to tell me before I get you into your breakout room who's female. They raise their hand or they put in the chat they're female. And I'm going to put all of those people in a Zoom room together or in a Teams room, whatever you want to use is fine. And now those females are all together. We knew at the beginning that there are 40 females. So I see just 40 students together. It's out of 40. Now I say, okay, of the people who just told me you're female, who went to an in-state high school? They're going to raise their hand for me or put a reaction or something. So looking just at the female students, we'll use a blue color. Looking just at the female students who went to an in-state school. The 30 here. That's it. Just those 30 students. Probability of in-state, given that female, is 30 out of 40. How else can we look at this? I want it to be the probability of in-state and female out of the total probability of picking a female student. Well, we picked up in-state and female earlier. That was 30 out of 100. Probability of female, well, there's only 40 female students out of 100, so it's 40 out of 100. Well, that's cool. The hundreds cancel out and you just get 30 out of 40. You can use the formula if you want. You can use the contingency table if you want. I think the table's pretty powerful. Formula is pretty cool too, but sometimes it's not as straightforward. Sometimes there's some overlap or other situations can have happen. I think that's all I have. Let's just practice one more. Let's look at another one. What if I wanted to find the probability of out of state given that male? Yeah, why not? Well, that means I say all the males, raise your hand. Raise your left hand, let's say. So how many males are there that raise their hand? Well, how many males are there? Males, there's 60. So I'm going to have 60 males with their left hand up. Now raise your right hand, males, at the same time if you graduate from out of state school. Looking at just my males, my out of state, there's 20 of them. So I should have 20 males with both arms raised up. Alternatively, using the formula, that's the probability of out of state and male divided by the probability of selecting a male student. I know that there are 60 out of 100 male students. Now, out of state and male, out of state and male, let's highlight this way as well. We double highlighted the 20, so that's 20 out of 100. The hundreds would cancel and you get 20 out of 60. We'll go over some more complicated conditional probabilities as well, um, probably on our free days or in our group activities. But this is how conditional probability works. You know some information that reduces your sample space. Then you just look at more information from that group itself. If you have any questions, don't be afraid to ask. I'm just an email away. Thank you so much. Have a great rest of your day.